Okay, guys. So today we are going to learn about expressions of concentration. So basically, there are many things that are within this PowerPoint, but actually, what we are going to talk about will be about percentages, okay, and parts per million and parts per billion. So here are all the things that we are going to learn today. So hopefully, uh, everyone would understand the concepts behind this. And this is just an overview of what is percent. So as you all know, your percent is the one that we are ratioing to 100. Okay, so it's a term corresponding to the sign which is percent, meaning by the hundred or in 100 or rate per hundred. So as you can see, if you have 12.5%, it means that there are 12.5 parts or grams per 100 ml of a certain solution. Okay, so you can read all of these things and we will proceed with your different percentage preparations. So as you all know, these different percentage preparations, we do use them whenever we are being asked as a pharmacist to mix certain drugs in the pharmacy. So sa amon practice, mismo sa hospital, what we do is to actually, we are being asked by the doctor to make, for example, 5% KCl solution. So it means that in a 100 ml solution or solvent, I mean of water, you add 5 grams of your KCl. So of course, it's not just about 100 ml of solution ang napahimo sa aton perme. So we will be asked of doing 50 ml, 75 ml. So all of this percentage preparations, these are the things that we could use in order for us to derive such formulations. So as you can see, we have percent, weight in volume, and volume and volume, and weight in weight. So here are the different things or different preparations into which we are applying this different percentage preparations. So of course, if we are talking about percent weight in volume, these are of course your solids that has been suspended or that have been suspended in your solvents. So the preparations for that would be your different solutions, NaCl into water, or your suspensions, ang mga amoxicillin na bala, pag mga antibiotic ta, or maski ng biogesic din, ablang suspension, makita nyo, solid na siyang nakasuspend sa aton solvent. We also have the volume in volume, of course, your liquid is a solute, or I mean the solute is also liquid, and then you will dissolve it on a liquid solvent also. So we use this one when we make emulsions. So oil in water emulsions, we could use this in okay, doon mo na siya. We can also use the percent weight in weight, so solids or semi-solids. So with this one, we have what we call different bases, such as petrolatum jelly. So do you know that? We have also organogels. We have also sorbitols. These are kind of bases that are semi-solids. And those semi-solids can be melted at certain temperatures. And that's the time that you are going to incorporate certain solids in them. So whenever, mga jelly ta guys, whenever the temperature is now cooled down, diba? So that's the time that you will have a hard mixture. So we use percent weight and weight in order for us to calculate it. And also we have the weight and volume. So usually we use this in gases and liquids. So these are your aerosol preparations. Okay, so we'll proceed. So you can read on the different side notes there. So this is your percentage calculations. So this is how they look like. And what we are going to do is to solve your percent weight and volume. Guys, it's just easy. Always just take note that your unit, whenever you're going to solve for this, is that your solute must be in grams and your solvent must be in ml. So for your percent weight and volume, let's proceed. Always remember, guys, that when we talk about solution, it is the amount of, when we talk about solution, it is always about the solute and your solvent. So if you have 10 grams of NaCl and 90 ml of water, that comprises about 100 ml of your solution. Okay, ml of your water could be just interchanged into grams. Okay, so they are quite equivalent. So, hindi ka kasulat sa hindi siya slideshow, guys. Okay. So, slideshow na lang ko. I think kasulat na ko. Okay. So now, let's proceed. So this is just an easy problem, such as your problem number 1 here. So what is being asked is how many grams of dextrose are required to prepare 4,000 ml of a 5% solution. So of course, guys, with the formula, the formula for your percent weight per volume is just the grams of your solute over ml of your solvent times 100. That would be it. So whenever we go back to the problem here, how many grams of dextrose are required to prepare 4,000 ml? What we are given was the ml of the solution. Ay guys, sorry. Solution na di siya. Total amount of the solution. So now, what we are given was the ml of the solution, which is about 4,000 ml. And what is being asked of you is the grams of your solute. So times 100. And of course, you were given the percentage of that solution, which is 5%. So of course, guys, what you should do is just divide the 5% by 100. So that would be about 0.05 multiplied by your 4,000. We are just transposing the formula. So what happens is 5% divided by 100 multiplied by your 4,000. So 5 times 4,000 ml divided by 100. That would be the amount for your solute. Okay, so input it in. That would be how much? 4,000 times 5 divided by 100. That would be about 200 grams of your solute. So it means that out of your 4,000 ml, its 5% would be 200 grams. Okay, so that would be it. Next, the problem was to what is the percentage strength weight per volume of a solution of urea if 80 ml contains 12 grams. So with this one, they are indicating that your 80 ml is the total ml of your solution. So just substitute directly to this formula. So this is the number 1 problem. This is the number 2 problem. So weight per volume in percent, your urea ko na pila to 80 ml. And it contains about 12 grams of the urea. 80 ml solution overall ni siya, guys, ha? So times 100, that would be the percentage weight per volume of the solution. So 12 divided by 80 times 100, that would be 15. Okay, so 15%. So we're done with this, guys. Let's proceed. With your volume and volume, it's just easy. It's still the same, but what we are using is a liquid solute. So with this one, how many ml of the liquefied phenol should be used in compounding the following prescription? Okay, guys, as you can see, your liquefied phenol is the one that is our solute. Your calamine lotion is our main solvent or our main vehicle for this formula. So what we should do is again, it's just the percent volume per volume. You were given already the value. So that would be 2.5% equal to ml of solute, which is, of course, that's the thing that we are still looking for, over the ml of your solution. So the overall, guys, ha? So 240 ml of solution. So that would be 240. Again, that would be 2.5% times 240 divided by 100. That would be the answer to the ml of your solute. Okay, so 240 times 2.5 divided by 100. That would be 6 ml. It means that your 6 ml of liquefied phenol comprises 2.5% of the whole solution. So, ang 6 ml mo, 2.5 na siya, sang imo nga 240. So, gets lang? We'll proceed. Okay. So, we have now your percentage weight in weight. So, your percentage weight in weight, guys, would be just representing again, your solute would be in grams, and also the solvent that you will have would also be in solid form or semi-solid form. So with this problem, so let's have problem number 1 also. So problem number 1, it's still the same process to that of the problem that we solve in your volume in weight. We also have number 2. So in number 2, you are being asked if 1,500 grams of a solution contains 75 grams of a drug substance, what is the percentage strength of the solution? So guys, ginhambalan ka na mismo nga overall 1,500 grams ka na. So you also have the 75 grams of the drug. So just directly again substitute it. Weight per weight. It's still 75 over 1,500 grams times 100. That would be equal to 75 divided by 1,500 times 100. That would be, guys, 5%. Okay, so your 75 grams out of 1,500 grams would be 5%. Okay, we'll proceed with your milligrams percent. So as we all know, your milligrams percent would be all about having the unit milligram per ml, okay, compared to that of your weight per volume, weight per weight, and your volume per volume. So as we can see here on your sample problem, we have the 4%. So your 4% in your weight per volume would be represented by 4 grams of solute over 100 ml. So what you should just do is to convert the 4 grams into 4,000 milligram per 100 ml. And you will get about 40, and then you will multiply it to 100, and then you will be given 4,000, sorry, hindi kayo go, 4,000 milligram percent. So it is a valid number. So usually your milligram percent would be out of ranges because it's not based on 100. So if you have 4 grams over 100 ml, that would be 4%. If it is in milligram percent, okay, so that would be 4,000 milligram per 100 ml. So when you divide that 4,000 divided by 100, we will have 40. So times 100 again, that would be 4,000 milligram. So guys, maskin tuluko nyo na lang gani, di ba 4% ka, kay 100 man nato ginabasihan. So si 4% ta, if you are basing only to 100, it is automatically nga may 4 grams ka nga solute. If it is in milligrams, and it's still in 4%, you just want it to express in milligrams since amo ning aton nga measure sa mga dugo ta kay gagmay, mas gagmay ang particles sa aton dugo, that would be 4,000 milligram per 100 ml. And you can conclude that the milligram percent would be 4,000 milligram percent. So it is a valid value. So next, we will proceed with your second question here. So if a patient is determined to have a serum cholesterol level of 200 milligram, what is the equivalent value expressed in terms of milligram percent? So usually, guys, a problem, may per DL na di siya, per deciliter. So when you write it, that would be 200 milligram per deciliter. So actually, what is being presented in here would be there is 200 milligram in every 100 ml sample of your blood. So, every 100 ml mo, may cholesterol da nga 200 mg sa patient mo. So, how will you express this into milligram percent? So, of course, di ba mo ning gina-after ta nga unit? Since this is in milligram and ml already, si deciliter mo, guys, equivalent na siya sa 100 ml. Okay? So, what you should do is just divide it and then multiply by 100, and then you will get again the 200 milligram percent. So there is 200 milligram percent of your cholesterol on your body. So with this 200 milligram percent cholesterol, you are being asked on the question B, how many milligram of cholesterol would be present in a 10 ml sample of patient's serum? Actually, you can use ratio and proportion, but we'd rather use this one kasi syempre para lain naman yung method. So we have 200 milligram percent already. And what is being asked in the problem would be the milligram of cholesterol. Of cholesterol if we do have the 10 ml sample. So times 100, that would be about 200 milligram times 10 ml. We are now transposing the formula divided by 100. That would be equal to the milligram of cholesterol in 10 ml sample. So what is the answer? That would be, 200 times 10 divided by 100. That would be, guys, 20 milligram. So, mas kini ratio and proportion you guys, makuha nyo na siya gapon. But this is how you use your milligram percent. Now, we'll proceed with your ratio strength. So, when we talk about ratio strength, guys, basically what we are talking about is just for you to get the least common denominator. So, or the simplest term of your fraction. So, for example, you have 1% weight per volume solution. It means, di ba, nga may 1 gram ko sa solute over 100 ml. So, this part or this writing is in your simplest term already na. You can't really change it because 1 na nga daan ng imo nga pinakanubo. But, for example, we have the 5%. It means that we have 5 grams out of 100 ml. Or 5 grams over 100 grams, it depends kung anong atong unit nga ginagamit. So, as you can see, this is still not in your simplest term. The simplest term for this one would be what we call now the ratio strength. So, 5 grams over 100 ml. In order for me to convert this percent weight per volume, what I would want is for me to have it ratioed to 1 part. Automatic na siya, guys. 1 gina din ang ipares mo siya. So if my solute represents 1 part or the simplest term of my part of the solution, what is my solvent part? So basically, guys, amo lang gina sulit pinakagamay lang. So that would be x grams or x in ml kay naka gram per ml ta times 5 grams is equal to 100 times 1 part. So x would be equal to 100 times 1 divided by 5 grams. So 100 divided by 5, that would be 20. So it means 20 parts. It means, guys, that the lowest term of 5 grams per 100 ml or your weight per volume converted to your ratio strength would be your 1:20 parts. So, kumbaga, again, lowest term mo lang siya, pero ang panawag sa niya is your ratio strength. So, I hope it's clear. So, are, amo ni siyang gin-explain ko bago lang. So, we'll proceed. It's here. If you would want to convert certain percentage concentration nga preparations into ratio, just always use 1 part. Okay? Ang sa dalo mo dayon x na siya. Then you will get the simplest term of that. But what if you were given the ratio strength already and you would want it to upscale, diba? You upscale it. Or you relate it into your weight per volume, or we would want it to relate to 100, diba? So you were given a ratio strength of about 1:10,000 weight per volume. Hindi mo na siya lowest term, kaya mo na siya gani ang lowest term ta. Naka 1:10,000 na siya. So if I want it to convert to weight per volume, what should I do? Sulit naman niya, guys. Ang x naman ang sa babaw. And what we should relate it to is the 100 ml. It's easy, no? So if you want it to convert to ratio, just use 1 above, x ang sa dalom, if we would want to relate it to 100 in order for it to become a percent weight per volume na value, then just put X above and then we'll put 100 to it. Okay? And the resulting amount for that would be the one that will be representing your whole solute that could be dissolved in the 100 ml solution. Okay, so from here we are going to solve for the example for your ratio strength. So express 0.02% as a ratio strength. So as you can see again, 0.02% would be about 0.02 grams over 100 ml of your solution. So in order for you to get your ratio strength again, ano gani? We should just use one part. Okay, you relate it to 1 and then just put X below. So in order for you to get the X part, that would be 100 divided by 0.02. So we have about 5,000. Yes, 5,000 parts for this one. So we have 1 is to 5,000 parts as your ratio strength. Okay, for 0.02%. So recheck. Check naman sa akong calculator, guys. So next, we have number 2, express 1 is to 4,000 as a percentage strength. Again, 1 over 4,000 because we want a percentage. Again, just relate it to 100 parts in here. And then this part will just be X. So 100 divided by 4,000, that would be your X would be 0.025 parts. So the percentage strength is about 0.025 grams pendesimo over 100 ml. So overall, this type of thing times 100, that would be representing about 2.5%. So 2.5% is your percentage strength. Okay, so that would be it. So for number 3, try to solve on your own if you can get it. And just make sure that you're consistent with your gram per ml. Okay, so parts per parts as long as ang ginagamit ng mga unit lang. So next, we have what we call your parts per million. So guys, ang parts per million, we are using this if ever we are going to incorporate chlorine sa aton nga mga swimming pool or sa mga tangke, sa basiwa. So in order for us to disinfect this large amount of waters in safe values. Okay, nga parang hindi man ta toxic. And also, read this trivia. It's all about the chlorine that we add into your dental health nga mga products, 'di ba? So we also add a little bit of your chlorine also sa inyong mga tubig para hindi ta ma-infect sa mga harmful nga cholera and other pang mga agents. So what else? Parts per million, of course, this is representing 1 part of a solute over 1 million parts of a solvent. Imagine. Dako, no? So what you should just remember with your parts per million is this unit. mg per liter. No matter what, maskin do ka budlay, sang formula and stuff, you can also use milligram per kilogram. Maskin do ka budlay, sang pang pamangkot sa inyo, tapos ano gid man times 1 million gid man ni or ano. What you should do is just convert everything into milligram per liter and milligram per kilogram, divide them together, then you're finished. So, for example, with this kind of problem, with your parts per million, we could actually use this formula, to which this is grams of solute again over ml of solvent, lang times 100 times 10, sorry, times 10 to the 6th, or what we call your 1 million, that would be equal to our ppm. Or if you don't want your life to be miserable, just use again your milligram per liter. So instead nga maamo ka pa ni kag ma-multiply sa 1 million, the proportion of your milligram to liter would be equal to 1 part is to 1 million part. Okay? So let's have this problem above. Din ang question number 1. Madula. Okay, so let's have the problem here. The concentration of a drug additive in an animal feed is 12.5 ppm. How many milligrams of the drug should be used in preparing 5.2 kilograms of the feed? So this is just substitution. So we do already have the answer here. So let's try to get the answer. So 12.5 ppm, because we were given already with the ppm. And what we are being asked is the grams of my solute. Okay? So, grams or milligram of your solute na lang gali guys kay milligram per liter ta. So, if not milligram per liter, we could use also milligram per kilogram. So, since naka-kilogram naman nga daan yang ako niya solvent, what I should just do is to directly multiply both. Okay? Times 5.2. Okay. So let's put 5.2 kilogram here. So just transpose the formula. Milligram of the drug. So 5.2 times 12.5, that would be 65 milligrams. So diretso na tayo nga daan guys, no? Wala na sang damo pa nga gamo. But if you would want a harder life, harder life, gudya, you can use this one, gram of solute, gram of solvent. So, matabo is ma-interconvert ka man gyapon. So, just basically use your milligram per liter and do not multiply na lang sa 10 to the 6. So, same goes with your parts per billion. Okay, so sa parts per billion mo naman guys, convert everything that you're being asked into microgram per liter and microgram per kilogram. Then, that's it. Wala ka na kinala niya guys nga ma-multiply sa 100 and stuff like that, multiply sa 1 million because ang unit mo na nga daan ng aton gin-fix. Naka-convert na siya. Okay? So, you can't, si ppb taya times 10 to the 9, si ppb. So, kung amo ni siya itsura ang aton niya mga units na kinahanglan niya i-interconvert would be this one. Okay? So, this problem, ang gina-focus na naman is for you to just convert your the 4 ppb to be expressed in your ratio strength. So, of course, 4 parts per billion, that would be 4 parts in 1 billion parts. So, ang himuon nyo lang guys is again to 4 parts over 10 to the 9 parts. Again, ano naman tayo mo tagani? I1 na naman di sa babaw kag x parts sa dalo. So, kung pila di si x, amo na siya ang gina-express ta as ratio strength. And for your percentage strength, the